Hey everyone, this is a follow-up to the previous video that we did. So if you haven't watched the previous video, go watch that one first before you come back to this one. In the previous video, we did the first pass of the smart contract. In this video, we'll be diving into some of those potential exploits in more detail. So let's get started. Okay, at this point, we've done the first pass through the contract, and so basically what I'm just doing is I'm going to go through all those audit comments I left using the inline bookmarks tool and click through each and every one of them and just double sanity check myself basically. And what we'll find is that while we're doing this exercise, we'll find other things that I didn't mark initially. But sort of those bookmarks are like flags I'm putting in my journey as I'm auditing, right? So that I can go sort of climb the mountain to that flag and then look around that flag and see, okay, is there something specifically to this flag, but also look around and see, is there anything else around it that I need to look at? So here's actually the first thing I wanted to look at. They have this distributor contract, and the idea of this distributor contract is that it will receive rewards from another contract via this fallback function. And the idea is that it will sort of siphon off a portion of those rewards, pay it to the royalty receiver, and then the rest will go to the crowdfunding address. When I first wrote this comment down, it was in the first pass. You probably watched me write this down in the first video. I didn't really have a good understanding of like who controlled these royalty or crowdfunding addresses. With hindsight, I know that they're sort of trusted addresses, and so they're not going to re-enter. It's not a problem. But one thing I realized while I was sort of going through my mental model and like realizing I was going to have to explain this in a YouTube video is that I don't always write POCs specifically to sort of prove that there's an exploit there. Sometimes I'll write them just to get a deeper understanding of the code. So I feel like you get a deeper understanding of the code versus just reading the code if you're sort of like kind of writing unit tests. And also one thing I get to do when I'm writing these unit tests is I get to play around with parameters and see kind of how that affects the outputs of the smart contract. So what I'm doing here is I'm writing a POC, and I'm actually going to write like a re-entrancy POC just to see like what happens if these things do re-enter, even though they are trusted addresses. I don't find anything too critical here, but there's another comment that I dropped here where I say something like, check C. Michelle's comment about, multiple transactions, outputting the same value. So C. Michelle gave a talk to Y Academy a couple weeks ago, and in it he was talking about different classes of exploits that he finds as part of his audits. And one of them is that, like if you took, let's say a trade for, $10 million and you broke it up into 10 million $1 trades, the output should be identical. Like you shouldn't be losing money, or the contract shouldn't be gaining money, or an attacker shouldn't be gaining money if you sort of treat these differently, right? And so that's sort of what I'm saying here is like, okay, not only should we try and do this re-entrancy bug, but we should also confirm that like if this fallback function gets triggered multiple times with smaller amounts, it should be idempotent. Like it should be exactly the same, the output. And so these are some of the things I'm testing out in this POC. Like I said, it turned out to be there aren't any findings here, but what it did is it gave me a better understanding of like how is this distributor function supposed to work. Like I said, I realized, okay, these are actually protected trusted addresses, and so like, okay, now I have a better understanding of that as well. And I've got some code to sort of like get the juices flowing as I continue to write more and more POCs as I'm looking at the code. So I've edited ahead, and what you're seeing here is basically just a happy case test for the distributor. It's just depositing 10 Ether into the contract and then asserting some post conditions about the contract based on parameters when I deployed the distributor contract. So what I mentioned before is that like a POC isn't always about like, okay, I know with certainty there's an exploit, I need to prove it. Sometimes in this case, right, I've got a happy case test, and I can start tweaking these variables, right? If I wanted to deposit 100 Ether, like how does that change things? If I want to tweak some of the deployment parameters of the distributor contract, how does that change things, right? I can start playing around with this contract kind of in isolation. You can see here what I'm doing is I'm starting the initial implementation of like checking this multiple transaction constraint that C Michelle did, right? And so what I'm trying to do here is go, okay, if I deposit 10 times 1 Ether rather than 1 time 10 Ether, then what are the expected post conditions here in this case? And here I'm just showing you that like, okay, I finished coding this up, and in fact, like it outputs what you'd expect. So I'd call it kind of an idempotent contract where like, okay, it doesn't matter how many times you run this, the outputs are as expected, which makes sense. I mean, if you actually go back and look at the distributor fallback function, it's a very somewhat simple function. There's no external calls or anything like that aside from transferring the Ethereum. So this contract has it's called buy lots. It's a function where you're sort of like buying up lots of these NFTs, and based on which NFTs you own, you can claim rewards and stuff like that. It's sort of irrelevant to the point I'm trying to discuss here, but that buy lots function actually has a re-entrancy. And so what I'm doing here is I'm writing up this exploit to actually re-enter into the contract. Now the thing is, I know that the re-entrancy isn't going to be exploitable, but as I said before, I like to write these POCs regardless because it gives me a way of sort of monkeying around with that chunk of code. In this case, I actually come up with I find a different vulnerability than a re-entrancy vulnerability, which I'll edit the video and we'll talk about that when I'm actually writing the comment. But the point I'm trying to make here is like, okay, yes, I'm writing this re-entrancy exploit, even though I know I'm not going to be able to steal funds from the contract doing it. It's still useful. Like it sort of drives home the point I was making before, which is it's still useful to write this POC because it gives you a different perspective on the code as you're auditing it. Another thing I wanted to test as part of this re-entrancy is like, okay, maybe I can't re-enter back into the same function call, but can I re-enter into a different function call of a different contract and change some state that this one depends on and then re-enter back into this function or something like this, right? It turns out all these are safe, but it speaks to like, okay, it's like the same way you write code, you're incrementally adding logic. I'm doing the same thing with exploits. I'm incrementally writing exploits. When I was talking about the distributor, right, I wrote a very basic test. It wasn't even an exploit, it was just a test, right? But then it allowed me to monkey around with it, right? I'm doing the same thing here with this buy lots function. Okay, at this point, I've basically written the re-entrancy exploit, and I've found, okay, like it's fine. There's no exploit here, and so what I'm going to do is I'm going to go back to the original code, and I'm going to mark that issue as okay. One of the things I'm noticing as I'm like revisiting the editing of this video is I'm very skeptical of this lot price times the number of lots sold variable that I marked in the previous video as something that's probably incorrect. So what I'm doing here is like after I've revisited it again, I'm like, I think this might be a good invariant to fuzz and like just confirm that the balance is the same in all cases as this lot amount times the lot price. A little later on in the audit, I actually write a test for this, and I don't even need to fuzz it. Like it's just blatantly wrong. So I had another comment above this function saying like, what is this used for? Because right now it's just an external view. So it might be that this miscalculation, it might not be a miscalculation at all, right? Or it might be that this miscalculation is just for like showing something on the UI and is actually not that critical. But it's something worth asking of the developers nonetheless. So the next function I wanted to move on to is the refund function. Another reason I like to do this first pass, second pass thing is the number of comments that I leave in a particular function can kind of help inform that I need to spend more time on a function or not, right? So it kind of tells me how dirty the code is in that section and whether or not I need to spend more time thinking about various exploits. So you can see there were 2 comments from the first pass, which means, okay, there's probably something here. So one of the things I wanted to look at in more detail was, so there's this stake royalty function and this claim function, and they sort of play with one another, right? You can see below on line 171 that per lot royalty that's calculated on 165 is sort of used to determine how much a user can claim. And what I thought was interesting about this is that per lot royalty is a global contract variable. So it's for the entire crowdfunding contract that per lot royalty is calculated. Usually when you're dealing with stakes, that isn't the case. And so what I wanted to do was I wanted to play around and see, with multiple actors kind of staking and claiming, is there anything interesting that happens as a consequence of that? So we pull out our handy dandy foundry. luckily I'd already, like I said, written tests before on this, so all that test code is already available to me, right? Like I said, I'm sort of building up these exploits, so I can reuse a lot of the code that I written for these previous potential exploits here again. And you could see previously that that test was called test multiple actors. So at this point, I'm just playing around with like, okay, if this person stakes this amount and another person claims this amount, then what are the post conditions? Are those expected post conditions? Or is this something the developer would want to see happen or not? And this is when things start to get more interesting in the audit. Um, this is sort of our first non-obvious bug that I find. And it's maybe not even a bug, but it's just something that the developer probably didn't consider, which is that anyone can stake the royalty, right? So even if I don't have a lot that I've previously purchased for this contract, I could technically send Ether to this contract, and basically it just swallows my Ether. There's no way for me to get that Ether back via any sort of mechanism. So this is sort of the first time I find something that's like, okay, on first pass of this code, you wouldn't really notice that. So here's another finding that's maybe not obvious at first glance. The per lot royalty is incremented by the amount divided by the get lot number sold out. And the problem is if this ratio is ever less than 1, the per lot royalty is incremented by 0, but the amount of Ether is still taken by the contract. This is like a classic case of Solidity bugs, because you're using uints all over the place, and so they don't count for decimals. And in this case, that's what's happening here. Here's another one that's not necessarily a bug, but I think probably should be in the audit report nonetheless, because I don't think the developer is maybe aware of this. And that is the fact that a user doesn't need to stake any royalties in order to withdraw Ethereum from the contract. Because like I said, that per lot royalty is a global variable. Basically, I could just sit around and wait for people to stake a bunch of royalties and then call claim, and I can withdraw a bunch of Ethereum out of the contract. And here is perhaps the most interesting bug that I found during the audit, and that is they have this concept of a lot ownership array, and whenever you're buying a lot, that lot ownership variable gets sort of marked as your message.sender. The problem is you can do a refund, and when you do this refund, they delete the lot book, but they never delete the lot ownership. So you still having been marked as being the owner of the lot, and so basically your ownership is never renounced, even though your Ethereum is sent back to you. The problem is that they use this lot ownership variable to mint the NFT, and so this means that you could theoretically claim a bunch of the lots, do a refund, and then submit a bunch of signatures to say that you still own those NFTs and have those NFTs actually minted to you. So the last thing I looked at was this signature replayability that I mentioned in the previous video. And in fact, the signatures are replayable. The only reason that it's safe, though, is that they're calling batch mint. So they're using these signatures to ensure that the appropriate owner can mint the NFTs. And a mint can't happen twice. So even if they were able to replay this signature, the mint would get rejected on the second case. I'm still going to probably push that they make the signatures not replayable, just in case they do some sort of refactor in the future, and like maybe they want to do something other than minting an NFT. In that case, that would introduce a massive bug because you could replay the signatures. So I think usually it's better to be safe than sorry. That said, I understand developers sometimes they need to weigh their own trade-offs, and gas might be one of them. This is actually something that happens very often in an audit. You'll find a bug that's like pretty big deal, and the developer just gets lucky that it's not like a critical vulnerability. It's not something that they caught necessarily. And I don't know, maybe these guys did. Maybe they were like, oh, we don't need to worry about signature replays because you can only mint an NFT once. I doubt that's the case, though. It's very often that you find vulnerabilities, but then the unfortunate thing is like, okay, there's nothing you can do about this. You can't steal funds with it or anything like this. And then it just becomes like an interesting observation, unfortunately. If you like that video and you are interested in learning how to be an auditor yourself, I have put together a document of all the resources that I used to learn how to become an auditor myself, starting with basic Solidity, learning how to code in Solidity, all the way through to some boot camps, capture the flags, and a list of auditing firms that are hiring auditors right now. So a link to that document will be in the description of this video. It's only $100. I've seen other auditing firms charging upwards of $2,500 for the same content. And since you're coming from my YouTube channel, I'll be giving you 20% off as well. So enjoy.